Hello everyone, welcome back to another chemistry video with the
Chemistry Co-Calb
and friends. Today we are joined by Game Story, Mars, Mental Breakdown, and rieth andal. Today we are going to show you guys how to weigh salt. Okay, let's get serious for once in our lives. We know that electrolysis is the breaking down of ionic compounds, molten or in aqueous solution, by the passage of electricity. We are going to use this definition to conduct an experiment in producing chlorine and hydrogen gas. We know that table salt, which is what we'll use in this video, is an ionic compound of sodium and chlorine. Looking closely at this compound, we know that sodium is a positively charged ion, which is also called a cation. Chlorine therefore is negatively charged and called an anion. The cation will be attracted to the negative terminal of a cell, but the anion will be attracted to the positive terminal of a cell. In other words, the cation is always attracted to the cathode, and the anion is always attracted to the anode. For this information, we can predict that in an ionic solution of sodium chloride, the sodium metal will build up on the cathode and the chlorine will be released as gas on the anode. However, we need to keep in mind that this is an ionic solution and water is involved in the reaction. Water molecules provide H+ and OH+ ions, hydrogen and hydroxide ions. These are positively charged ions and would be attracted to the negative electron along with the sodium ions. We know that in ionic compound electrolysis reactions, if a metal is more reactive than hydrogen in the reactivity series, then the metal will not form, and hydrogen will be released instead. In this case, sodium is indeed more reactive than hydrogen, so our final prediction will be an electrolysis reaction where hydrogen and chlorine gas are released. In this experiment, we are expecting a redox reaction. The hydrogen ion gets reduced in the cathode and the chlorine ion gets oxidized in the anode. The hydrogen ion gains an electron and becomes a hydrogen molecule, which is hydrogen gas. Same thing happens to the chlorine ion. As it loses an electron, it becomes a chlorine molecule, which is chlorine gas. Remember, in redox reactions, positively charged ions are usually the ions that get reduced, since they gain electrons during the process. And negatively charged ions get oxidized in the anode because they lose electrons in the process. Let's move on to the experiment. In this experiment, we use table salt, water, batteries, copper wires, and a container where you can set up your electrolysis setup. Oh, and of course, you're going to need a spoon or a spatula to store the salt and water. So how do you do this experiment? Well, first off, get 1 spoon/spatula of salt in the container of water. Make sure you stir it thoroughly, like how Solar is doing it right here. Now, use the copper wires connected to the batteries and dip it into the solution of salt and water. As you can see, as the electricity passes through the copper wires into the solution, the hydrogen gas immediately gets released in the positive terminal of the wire. As you can see by the red wire, there's also some fizzing action going on, and that's probably the chlorine gas being released. Now, have we achieved our prediction? Well, during the experiment we have seen the hydrogen and chlorine gas get released as the electricity passes through the wires. And this proves that the water and the salt compounds have broken down into their ionic forms and formed their gas molecules in the electrodes. This suggests that we have certainly achieved an electrolysis reaction, proving the prediction correct. So that is it for today, guys. I hope you guys enjoyed this little video we got here and hope you learned something. I hope you guys learned how to weigh salt. Other than that, Please take care during these times, and we'll see you guys next time.